Hello friends and students. So let's begin with the next exercise from the NCERT Exemplar, exercise 5.2. The chapter is Arithmetic Progressions. So the required formulas are an equals a plus n minus 1 into d. To find the sum to n terms, we have n by 2 into 2a plus n minus 1 into d, or it is n by 2 into a plus an. So let's begin with the first problem. Which of the following form an AP? Justify your answer. So the first one is minus 1, minus 1, minus 1, minus 1. So now if you observe this sequence of numbers, so if I subtract the second from the first, minus 1, minus of minus 1, I get 0 as the common difference. Subtract the third from the second, minus 1, minus of minus 1 again is 0, which is the common difference. So the common difference between any two consecutive terms is 0. So this forms an arithmetic progression. Second one, 0, 2, 0, 2. So here the common difference 2 minus 0 is 2. Next, third term minus second term, 0 minus 2 equals minus 2. The common differences between the second and the first and third and the second do not match. So this is not an arithmetic progression. 3, 1, 1, 2, 2, 3, 3 and so on. So here again consider the second term minus first term. 1 minus 1 is 0. The third term minus second term. 2 minus 1 is 1. So the common differences do not match. So this is not an arithmetic progression. Fourth one, we have 11, 22, 33 and so on. So second term minus first term, 22 minus 11 equals 11. Third term minus second term, which is 33 minus 22 is 11. Both the common differences are the same. So this is an arithmetic progression. Fifth one, 1 by 2, 1 by 3, 1 by 4 and so on. So second term minus first term, 1 by 3 minus 1 by 2. So here we have to take the LCM, which is 6, right? So you get 2 minus 3, which is minus 1 by 6. So the common difference is minus 1 by 6 here. Now subtract the third term and the second term. So you have 1 by 4. So let me write it here. So 1 by 4 minus 1 by 3. So the LCM is 12. So you get 3 minus 4, which is 1 by 12 with a negative sign. These two common differences do not match. So this is not an arithmetic progression. So you find that the first one is an arithmetic progression and the fourth one is an arithmetic progression. Sixth one, 2, 2 square, 2 cube, 2 power 4. So definitely the common difference is not the same because we find that the value is increasing by a factor of 2. So you have 2, 4, 8, 16 and so on. So the difference between the second and the first is 4 minus 2, which is 2. Third term minus the second term, which is 8 minus 4, which is 4. The two common differences are not the same. So this is not an arithmetic progression. Next, seventh one, root 3, root 12, root 27, root 48. So this can be written as root 3. I can write this as 4 into 3, the whole root. And this as 9 into 3. And the next one as 16 into 3. So you get root 3. So take 4 outside the root. So you get 2 root 3. Then here you get 3 root 3. And then 4 root 3. So second term minus first term, 2 root 3 minus root 3 equals root 3. Third term minus second term, 3 root 3 minus 2 root 3 is again root 3. So fourth term minus second term also will give me root 3. So you have the same common difference. So this is an arithmetic progression. Question 2. The sequence is minus 1, minus 3 by 2, minus 2, 5 by 2. Justify whether it is true to say that the given sequence forms an AP as A2 minus A1. So you have A2 minus A1 equals A3 minus A2, right? So this is the first term, A1, A2, A3 and A4. So what is A2 minus A1? Minus 3 by 2, minus of minus 1 is plus 1, which gives me minus half. Next, A3 minus A2. What is A3 minus A2? Minus 2, minus of minus 3 by 2, which gives me plus 3 by 2, which is again minus half. So here we find that these two, of course, are the same. It is minus half here, the common difference is the same. But now let me consider A4 minus A3, which is 5 by 2 minus of minus 2. So you get 5 by 2 plus 2, which gives me 9 by 2. Of course, 9 by 2 is not the same as minus half. So this sequence is not an arithmetic progression. So here we find that though the difference between the second and the first and the third and the second happen to be the same, we find that the difference between the fourth term and the third term does not match with the previous two differences, common differences. So therefore, this sequence is not in arithmetic progression. It's not an arithmetic progression. 3. For the AP minus 3, minus 7, minus 11, can we find directly A30 minus A20 without actually finding A30 and A20? Give your reasons for your answer. So here let me consider A30 minus A20. So what is A30? By using this expression, it is A plus 30 minus 1, which is 29D, minus A20 is again A plus n minus 1, 20 minus 1, which is 19D. Let me remove the bracket, so I get A plus 29D minus A minus 19D. A gets cancelled. So 29D minus 19D is 10D. And what is D? D is minus 4. So it is 10 into minus 4. So we get minus 40. And this is A30 minus A20. So without actually finding the value of A30 and A20, we can find the difference of A30 and A20 by considering the expression an equals a plus n minus 1 into d. Substitute value of n and subtract both of them. So a gets cancelled and finally you're left with 10d, and we know the value of d, which is minus 4. Question 4. Two arithmetic progressions have the same common difference. The first term of one AP is 2. So I have two arithmetic progressions. So the first term of one of the AP is 2 and the first term of the second arithmetic progression. So let me call this as A1 dash, and that is 7. The difference between their 10th term is the same as the difference between their 21st term. So A10 minus A10 dash is equal to A21 minus A21 dash. So the difference between their 10th terms is equal to the difference between their 21st terms, which is the same as the difference between any two corresponding terms. So in the next statement, it has been given that it is the same as the difference between any two corresponding terms. So if D happens to be the common difference between any two corresponding terms of the first AP, D also happens to be the same common difference between any two common terms of the second AP. So D is the common difference here. So we have for the first AP, so this is arithmetic progression 1. So it is 2, 2 plus D, 2 plus 2D, and so on. For the second arithmetic progression, it is 7, 7 plus D, 7 plus 2D, and so on. So now let's consider the 10th term. So what is A10? A10 is A plus n minus 1, which is 9D, minus A10 dash is A. So here A1 dash is 7 plus again 9D. So we find that 2 plus 9D minus 7 minus 9D. So 9D can be cancelled, so I get minus 5. Right? So if I subtract A10 minus A10 dash, I get minus 5. Similarly, if I subtract A21 minus A21 dash, so again you get A, which is 2, plus n minus 1, which is 20D, minus A, which is 7, plus 20d. And this gives me 2 plus 20d minus 7 minus 20d. So again we get minus 5. So from this we can conclude that if you have two arithmetic progressions wherein they have the same common difference d, then the difference between the first term and the first term of these two arithmetic progressions, the difference between the second term of AP1 and AP2, the difference between the third term of AP1 and AP3 and so on, they all will be the same, which is equal to minus 5, right? So here A10 minus A10 dash is equal to A21 minus A21 dash, and it's going to be the same if I take the difference between any two terms correspondingly. That means if I consider A3 minus A3 dash, again it would be the same, which is equal to minus 5. If I consider A5 minus A5 dash, again it's going to be minus 5. Fifth one, is 0 a term of the arithmetic progression 31, 28, 25? Justify your answer. So we need to check if 0 is a term in this arithmetic progression. So I don't know the value of n, so let this be an. So a is 31. What is d? D is 28 minus 31, which gives me minus 3. So an, which is 0, equals a plus n minus 1 into d, which is minus 3. So 0 equals 31 minus 3n plus 3. So this gives me 34. So 3n equals 34. And what is n? 34 by 3. So this is 11, 1 by 3. Can I have a value of n which is not a whole number? No, it's not possible. So therefore 0 is not a term in this arithmetic progression, which is 31, 28, 25 and so on. Problem 6. A taxi fare after each kilometer, when the fare is rupees 15 for the first kilometer and 8 for every additional kilometer, does not form an AP, as the total fare in rupees after each kilometer is 15, 8, 8 and so on. Is this statement true? Give reasons. So initially the amount is 15, and then for every additional kilometer, right? So for the first kilometer it is 15, and then for the next kilometer you have 8, 8, 8, 8 and so on. So what is the total amount? For the first kilometer it's 15. For the second kilometer it's going to be 15 plus 8. For 3 kilometers it's going to be 15 plus 2 into 8. For the fourth kilometer it's going to be 15 plus 3 into 8 and so on. So now let this be the first term, which is A1. Let this be the second term, A2, A3 and so on. So what is A2 minus A1? It is 15 plus 8 minus 15, which gives me 8. A3 minus A2 is again 15 plus 2 into 8 minus 15 plus 8, which gives me 8. And the fourth term minus the third term, A4 minus A3, is also equal to 8. So we get the same common difference. So therefore the total fare after each kilometer definitely forms an AP, right? So this entire sequence of numbers will definitely form an arithmetic progression. Question 7. In which of the following situations do the list of numbers involved form an AP? Give reasons. The first one, the fee charged from a student every month by a school for the whole session, when the monthly fees is rupees 400. So in first case, the fees for the first month is 400, second month is 400, third month is 400 and so on. So the value is 400. Right? So this is A1, this is A2, this is A3. So what is A2 minus A1? It's 0. What is A3 minus A2? It is 0. So the common difference D is 0. So this forms an arithmetic progression. The fee charged every month by a school from class 1 to 12, when the monthly fees for class 1 is 250 and it is increased by rupees 50 for the next higher class. So for the first standard it is 250, for the next class it is 250 plus 50, and for the next class, so that is for standard 3, it is 250 plus 50 into 2, and then it is 250 plus 50 into 3. So this is for standard 1. So let this be A1, A2, A3 and A4. Again we find that A2 minus A1 difference is 50, A3 minus A2 difference is 50, A4 minus A3 difference is 50. So the common difference is 50, and this definitely forms an arithmetic progression. So this is also an arithmetic progression. The amount of money in the account of Varun at the end of every year when rupees 1000 is deposited at the simple interest of 10 per annum. So rupees 1000 is deposited. And what is the simple interest? The simple interest is 10%. So we know that the simple interest equals the principal into rate of interest into time divided by 100. So the simple interest is 1000 into 10% into 1 divided by 100. So 10 into 10 gives me 100. So the simple interest is 100. So after every year he gets an interest of 100. So initially the amount is 1000, then it's going to be 1000 plus the simple interest 100 for the first year. For the second year it's going to be 100 into 2. For the next year it's going to be 100 into 3, right? The interest is going to be 3 into 100 and so on, right? So the interest gets added to the principal. So here you find that the common difference D is 100. Right? So if this is A1, A2, A3, A4, A2 minus A1 is 100, A3 minus A2 is 100 and so on. So this forms an arithmetic progression. The number of bacteria in a certain food item after each second when they double in every second. So let's assume that X number of bacteria is present in a certain food, and after every second it doubles. So the next second it's going to be 2x. And then it's going to be 2 into 2x, and then it's going to be 2 into, so next it's going to be 2 into 4x and so on. So here you find that the common difference. Let's find out the common difference. So A2 minus A1 is x, A3 minus A2. So this is 4x minus 2x, which is 2x. So the common difference is not the same. The difference is not the same. So definitely this is not in arithmetic progression. Moving on to question 8. Justify whether it is true to say that the following are the nth terms of an arithmetic progression. So first one, 2n minus 3. So let me find the first term. To find the first term, a1, put n equal to 1. So 2 minus 3 equals minus 1. A2 is put n equal to 2. 2 into 2 minus 3, which is 4 minus 3, which is 1. A3, put n equal to 3. 2 into 3 minus 3, which is 6 minus 3 equals 3. Then A4, put n equal to 4. 4 into 2 is 8 minus 3, which gives me 5. What is the common difference? Here we observe that the common difference here in all these cases happens to be 2, right? So A2 minus A1 equals 1 minus of minus 1, which is 2. Next, A3 minus A2 is again, the common difference here is 2. Again here the common difference is 2. So definitely this forms an arithmetic progression, and 2n minus 3 will form the nth term of an arithmetic progression. So this is true. So this forms the nth term of an arithmetic progression. Second one, an equals 3n square plus 5. Now we have to use the same logic. Put the value of n. For n equal to 1, I get a1, which is 3 plus 5 equals 8. For n equal to 2, I get 3 into 2 square. 3 into 2 square is 4 plus 5. So you get 12 plus 5, which is 17. And A3 is 3 into 3 square, which is 9 plus 5. So this is 27 plus 5, which is 32. Again, find the common difference. What is A2 minus A1? It is 17 minus 8. So you get 9. A3 minus A2, which is 32 minus 17, which is 15. So we find that the common difference is not the same here. So this does not qualify to be the nth term of an arithmetic progression. 3. 1 plus n square. So one thing what you need to remember is whenever you have the n square term in the expression, it definitely does not form an arithmetic progression. So here an equals 1 plus n square. So what is a1? It is 1 plus 1 plus 1, which is 3. a2 is 1 plus 2 square, which is 4. So you have 4 plus 2 is 6 plus 1 is 7. And a3 is 1 plus 3 square, which is 9. So you have 9 plus 1 is 10 plus 3 is 13. So here a2 minus a1, difference is 7 minus 3, which is 4. a3 minus a2 is 13 minus 7. The difference is 6. So definitely the two common differences are not the same. So this does not qualify to be the nth term of the arithmetic progression. So we observe that whenever you have an n square term or an n cube term in the expression for an, it does not qualify to be the nth term of an arithmetic progression. So this is one thing you can remember, especially if such questions are asked as a multiple choice question. So you don't have to waste time calculating and checking whether it forms the nth term of an arithmetic progression. So this completes all the problems from the exercise 5.2 NCERT Exemplar. So do not forget to like, share and subscribe and press the bell icon to get notifications of all the further uploads, and thanks for watching.